Okay, continue on where we left off. I got stopped because I ran out of time. It was 15 minutes time limit. We was doing this one right here. This one is done at the end of the year. That's why we do it this way. Whereas this one is done, you receive the payments at the end of the year, and that's why you have the 1.12 added to it, or at the beginning of the year, I'm sorry, at the beginning of the year, and that's what makes the difference. Okay, but I noticed the years are different. This is, you start here, the future value is 2022, this is 2023, so you have an extra year there that you're accumulating. Okay, here we have 7 equal annual contributions made. Okay, I want to try to pick up the pace a little bit so I can get everything done on this one, because we've gone through in detail how to come up with the percentages and that type of thing. This is table 2. Now this is a little bit different because on this one you want to know what are we looking for. That's the key. Determine the equal contributions if invested at 10%. So we want the payments on this one. So we have equal. We want 30,000. In this case, we're going to divide it by, and that will give us our payment of 3162.16. For the Excel portion, this is a different function. We go into the equal payment function. The rate is 10%, comma, number of periods, and the present value is 30,000, and it comes up with, what did I do? Oh, it's not an annuity, that's why. It's a one-time thing. There we go. It's a I needed a second comma in there. Sorry. Okay, because it's not an annuity. You don't get 7 equal annual contributions are made. 30,000 is not an annuity. Okay, so you have to make payments of the future value. It's not the present value, it's the future value is the 30,000. That's why you need the 2 commas. Okay. And with this one we have beginning on January 1st, 2017, we have 5 equal deposits are made into a fund. Okay, so that makes an annuity. That's why it's table 2. Using the appropriate table, determine the equal pay. Okay, so we have on this one, we have it's for 5 payments, 10%. So we look at a table 2, 10%, you come up with that number. And then you have equal the 150,000 divided by this one, it gives you 24,000. Okay, so over here then we'd have equal PMT. The rate is 10%. Number of periods, do 2 commas because the future value is 150. So we come up with this one. Okay, for this one we have, it's 6 periods away. It's still 10% interest, payment 2. Oh, this time we want to look at 2. This is a little bit different in that what we're looking for is the first withdrawal is to be made on January 1st, 2016. So yes, it's 6 periods away, but we want to subtract 1 from it. Okay. So what you would have then is equal to the 150,000 divided by, I want to write it in here this time, 7.71561 minus 1 and close. Okay? Because it's made at the beginning of the period instead of the end, so that's why you have to do it that way. Equal PMT. The rate, 10%, comma, we're still going to use 5 payments because that's what we actually are. I'm not going to use the 6, okay, and again it's the present value, it's the future value minus the 150. The difference is though I want this done at the beginning, and that'll take care of the extra payment that we have. So you see it comes out to the same. Okay, the reason why is when the payments are made. Using the appropriate table to determine equal deposits annually. This is 1 extra year here, so that's why it's 6 years, but you have to subtract 1 from it because it's still only 5 payments. Okay. Dennis Watts is to make 5 equal withdrawals of $10,000. Okay. So both of these are going to be 5 and 10%. And this is table 4 and table 5. Table 4, remember, is an annuity. Table 5 is an annuity due. This means it's at the beginning of the year. Okay? Because we don't have an annuity due for the other one, of the payment due. So this is equal to the 10,000 times the 3.7. And this one is going to be equal to the 10,000 times the 4.1 because you get it earlier. That's why it's worth more. Okay. Now this is equal to the present value of the rate is 10%. The number of periods is 5, not 10,000. And again, this is the present value. I think I did it right. Yep. Okay. Now this is at the beginning, so it's still the present value. The rate is 10%. Number of periods is 5. The payment is the 10,000, but the type is when you're receiving them is at the beginning this time, so that's a 1. So it makes a difference. See, this is received at the end. This one's received at the beginning, so that's what the difference is here also. This is at the end. This is at the beginning. So that's why you have to do it a little bit differently. Okay, Gypsy House borrows $10,000. So we got the 10,000 in there, and it's 0.1.5%. Where's Gypsy House? Let me find it. Okay, Gypsy House borrows $10,000 in equal 24 payments. So that's 24, and it's 1.5. And we need to home. Oops. There we go. 1.5. So we can see it. Okay, 4. So we go to 1.5% for 4. We get that 4. Table 4. And do say 1.5% for 24 periods. You come up with the 20. Okay, so now we want to find the payments, so it's equal to 10,000 divided by this amount, and that will give us the 499.24. And on this one, we have equal the PMT. The rate is 1.5% a month. Number of periods is 24 months, and the negative 10,000. Okay, so this is equal PMT D49, which is the rate. C49 is the 24, and then a minus B49. And if you do that, that'll give you the 499.24. Okay. January 1st. This is a 3-stepper, as you can tell. January 1st, 2016, Daniel Gardner borrows $40,000 from his mother to open a business. Okay, so he borrows $40,000. Daniel is the beneficiary of trust created by his uncle, from which he will receive $25,000 in 2026. Okay, so it's a good 10 years away. Daniel signs an agreement to make this amount payable to his mother, and further to pay his mother equal annual payments to January 1st. In retirement debt, interest is 12%. What are the annual payments? Okay, so first thing we have to do is find the present value of the trust fund. Okay, so we know that's 10 years from now, and it's 12% interest. So we go to table 3, that's the present value, and we come up with not that number, but that number, 0.321973. So for this one, for the table, we'll take this times this amount, and you get 8,000. Or if you did the Excel version, it's equal present value. The rate is 12%. Number of periods is 10 years. And we also then know the future value is 25,000. So what we want to do is find the present value of it. So that gives us 8,049.33. Okay. Step 2. So he owes him 40,000. That's not really a calculation. All we're going to do here is take equal 40,000 minus the 8,049.33. Okay, so that's our 31,000. Put it there. Okay, I guess 31,000. Let's put a commas in there. Okay, 31,950.67. And it's going to be the same for both of them because that's just the same calculation. Take the 40,000 and subtract it. Step 3 is you find the installments. So we have 9 payments, 12% interest. So that's table 4, 5.3. So then what we'll do is we'll take equal. We want to take that cell, divide it by this one, and you get 5.9947. If you did Excel version, equal PMT. The rate is 12%. Number of periods is 9. And the present value we just calculated right there. And you come up with the same payments. Okay, so that takes care of that one. All right. Then we have John Conal, $3,000, 6 periods, 10%. Table 4, look up the number. So we have equal the 3,000 times the 4 gives us 13,000. And this is a pretty straightforward one. Equal present value. The rate is 10%. Number of periods is 6. And it's an annuity, so it's minus 3,000. So you come up with the same results. Okay. If the funds earn interest compounded annually at 10%, okay. So it's 10%. Okay. So it's equal to what we just calculated up above here, divided by the 15. So that's going to be your payment. And on this one, it's equal PMT. The rate is 10%. Number of periods is 10. And this is the future value of it. So you come up with the same results. Okay.